Hello, and welcome to this presentation introducing Micro-Epsilon's high-precision 3D sensors for geometry and surface inspections. My name is Glenn Wedgbrow, and I am the Business Development Manager for Micro-Epsilon in the UK. In today's talk, I will introduce you to the 3D sensor portfolio from Micro-Epsilon. I will go through each of the measurement principles, give advice on which sensors to select for an application, discuss the ways in which you can process and output data, provide some examples of solved applications, and if there is time, answer your questions. We have 4 sensor types available in our 3D sensor portfolio. Surface Control 3D 3000 series for snapshots of small areas with high precision. Surface Control 3D 2500 series for snapshots of large measurement areas. Reflect Control 2D and 3D for surface inspection and shape recognition on reflective targets. And Scan Control line sensors for capturing 3D data from moving objects. The Surface Control 3D sensors work according to the principle of optical triangulation based on fringe projection. Using a matrix projector, a sequence of patterns is projected onto the test object surface. The light of the patterns diffusely reflected by the test object surface is recorded by 2 cameras. The 3-dimensional surface of the test object is then calculated from the recorded image sequence and the knowledge of the arrangement of the 2 cameras to each other. The video shows this in action. Warning, there is flashing images. The Surface Control 3000 series are a new generation of high-precision 3D snapshot sensors, offering highest Z-axis repeatability from 0.4 micron. They are a fully integrated industrial sensor with passive cooling, delivering up to 2.2 million 3D points per second. The 3D point cloud is delivered directly from the sensor. All our sensors support the new 3D UKIVA Vision GenICam standard for easy integration into existing 3D image processing tools. Surface Control 2500 has been redeveloped to the newest platform and is a 3D sensor for inspection of larger targets. Measuring fields are up to 650 by 495 millimeters, with high measuring range depth from 150 to 300 millimeters. Capturing time is around half a second, and the repetitive precision is up from 3 micron. Reflect Control is for 2D and 3D measurements on flat mirror-like surfaces. It consists of a large screen that projects light patterns onto the surface, which is evaluated by 2 cameras in the housing. The video shows the sinus pattern in action, the light pattern on the surface, and the resulting data capture in the software. The Reflect Control has 2 models. 2D measurement for surface inspection with a measuring field from 110 to 245 millimeters and outputs 2D images for the intensity, amplitude and curvature of the captured surface. The second model is for 3D measurement of the target, looking at flatness and waviness. It has a measuring field of 80 by 160 millimeters and also outputs the 2D data and in addition provides the 3D point cloud. The sensors offer highest repeatability of plus or minus 1 micron in a peak to valley, so that even smallest deviations in the range of just 10 nanometers can be detected. The Reflect control also supports the new 3D UKIVA Vision and GeniCam standards for easy integration into existing 3D image processing tools. Scan Control is our popular 2D line sensor that can now build up 3D data from the captured 2D profiles. The sensor is using the triangulation principle and projects a wide laser line onto the target, which is viewed by the CMOS receiver array and converted into a 2D profile line of X and Z coordinates. The 3D information is built up from a sequence of captured 2D profiles, which makes it especially useful for capturing data from targets where it is continually moving and is not able to stop. The Scan Control 3000 series are compatible with 3D measurement and inspection and are offered with a number of different measurement ranges which govern the line width for the sensors. The surface you are looking to capture can have a number of different characteristics, but the main thing of importance is whether a surface is diffuse or specularly reflective. When you have a matte or diffuse surface light that hits the surface, it will reflect in all directions. This means that you can view the light from a range of different angles. When the surface is shiny or specularly reflective like a mirror, then the light will reflect at the same angle off the surface, which means you must be at the exact same angle as the reflection in order to see the returned light. Surface control and scan control works best on matte or diffusely reflecting surfaces. That is to say, those that do not present a perfect mirror. For especially shiny and flat surfaces, we would use the Reflect control sensor. Both surface control and Reflect control require the target to be stationary for a moment in order to capture the 3D data. Scan control sensors do not need the target to be stationary. They can capture the data while the target is moving or if the sensor is moved over the target. For control of the 3D measurement, two methods are suitable depending on the configuration you have in your setup. The sensors can be triggered directly to start acquisition from the line PLC or via the host PC running the analysis software. The task of processing large amounts of 3D data will require a decent computer, preferably an industrial PC or similar. In addition, you have to think about how the data you process and the resulting measurement information is going to be transferred to the control system. Our sensors are communicating using the standard GeniCam and UKIVA Vision protocols. Once the data is processed in the PC, it must then be transferred to the control system. These days, that is often done through an industrial network like Profinet, Ethernet IP, or EtherCAT. We can see there being requirements for ensuring the ability of both data capture and transfer, so we offer a solution we call the Industrial Performance Unit. This is an IPC configured specifically to run our sensors and software and incorporating the necessary gateway architecture to talk to the industrial networks. We also envisage two customer types for the hardware: system integrators and end users. For those integrators with 3D processing software like Helcon or similar, we offer our documented 3D SDK with examples for various programming languages, so that they can create their own solutions to applications. For those who do not have the capability to write their own software code, we are also offering our new 3D Inspect software solution. 3D Inspect is created by Micro-Epsilon for 3D capture and evaluation. It is applicable to surface control, reflect control and scan control sensors with the latest firmware, and is available for free download from our website. The software concept offers 4 steps to getting results. Step 1 for data acquisition. Step 2, data pre-processing, which means finding and aligning the target within the coordinate system. Step 3 is evaluation of the data through various available tools. And step 4 is transferring the data to the outside world. Note that this element will require a license. Step 1, data acquisition. Make sure the sensor and the target are aligned. Here this is aided with the display image data. Capture the data and process it into the software. Next, for data pre-processing, we want to realign the captured data so that it is in line with the XYZ coordinate system. Here you can see the original captured data and then the converted data in line with the X, Y and Z planes. This then allows us to do the data evaluation, setting up various processes to inspect, for example, doing a plane fit. Once we've identified the targets, we can then combine them. In this example, look at the difference between the two. Finally, we can transfer the data output from the software. This can be done in a number of different ways depending on the configuration and the setup for your system. There are a wide range of functions available for analysing and measuring the captured data, such as measuring angles, finding spheres, circles, cylinders, determining flatness and distances between points or edges. The software is able to find a target based on its contour and readjust it to allow further inspection to be made. You can visit our stand to see more detail on this. And now I'd like to show you some application examples to give you a better glimpse of what the capabilities are. The high accuracy capability of the Surface Control 3D 3000 series makes it ideal for use in automated inspection of PCB and electronic components, checking for flatness of unassembled substrates, completeness of components assembled on the PCB, and distance checks and parallelism of those components to the base layer. In applications for plastic molding, the presence of sink marks caused by joining elements should be avoided. Here, Surface Control can identify shape deviation defects on the front side caused by injection molding, perhaps due to rapid cooling. The software is also able to remove underlying trends like curvature and make automatic pass-fail decisions. Another useful benefit is the capture of 3D text such as embossments, or checking for the finest details using the high precision of just 0.4 micron on small components. Surface Control 2500 is used for larger area inspection and has the added software option of our DefMap 3D software for further surface analysis. Here the requirement is to check the presence of the sink mark for the airbag without it being visible to the human eye. Another application of the DefMap 3D software is checking for surface imperfections on painted surfaces where a digital stone or simulated light tunnel aid detection of defects on fuel filler and charging caps for vehicles. Surface Control 3D is also employed to detect the presence of cracking or shape defects on pressed panels in the automotive industry. Additional applications for surface control sensors include testing of interior and exterior aircraft parts, such as rivet inspection, checking defects on white good casings or kitchen cupboard surfaces, and even testing of table tennis bat rubber. For Reflect Control 2D, using the sinus projection and evaluation of the intensity, amplitude and curvature, a wide range of surface defects on shiny or glossy surfaces like painted car bodies and mirrors can be detected. The sensor provides a much greater repeatability in defect detection regardless of the painted colour surface against that of a human operator or inspector. Reflect Control 3D takes the evaluation a step further and allows for the 3D data to be evaluated across nominally flat surfaces like a smartphone display. Note the scale here is only a few microns. Another example is for warpage measurement, such as bow and curvature of silicon wafers. You can keep updated on all things Micro-Epsilon through LinkedIn, so make sure you're following us. And also make sure you subscribe to our UK newsletter for product news and information about our next events and exhibitions. So that concludes my presentation, and hopefully now you have some questions for me. Thank you.